Right. So we're going to cover section 312 today, and we're going to, which is titled, How Can I Use a Graph to Solve the Equation? And the objective is by the end of the period, I will be able to use graphs to check algebraic solutions, to explore extraneous solutions, and to approximate solutions that cannot be solved. In the previous lessons, you used and named several algebraic methods to solve different kinds of equations and systems of equations. In today's lessons, you will again solve equations, focusing on how graphing can help you solve equations and check solutions. You will continue to make connections among equations, solutions, and graphs. So for problem 24, it says that in problem 3.1, you used a graph to solve an equation. In what other ways can a graph be a useful solution tool? Consider this question as you solve the equation square root of 2x plus 3 equals x by completing parts A through D, okay? So the first thing they want us to do is they want us to use algebraic strategies to solve that equation. Square root of 2x plus 3 equals x. How many solutions did you come up with, and which strategies did you use? Okay, so we're going to start with the equation. Because we're taking the square root, we're going to do the inverse operation, which we call undoing. So the inverse operation of square rooting is squaring. So we need to square both sides. That's going to be step number 1. When you square something that's being square rooted, you get what's inside. And when you square x, you get x squared. All right? Then I'm going to set this equation equal to 0 so that I can factor it, right? So x squared is already on the right, so I'm going to move the 2x by subtracting it. I'm going to move the 3 by subtracting it, and that gets my equation set equal to 0. So we have x squared minus 2x minus 3. So now I can take that trinomial and factor it. I'm going to fill in the first term, which is our x squared, in the first box, and I'm going to fill in the third term, which is negative 3, into the last box. Then I have to figure out what goes in this box and what goes in this box. We just need to get to negative 2. So it's not really large numbers, so it should be fairly easy, right? The only factors of negative 3 are a 3 and a 1, and obviously one's going to have to be positive and one's going to have to be negative, right? Since this term is negative, that means the larger one needs to be negative. So this should be negative 3. So what's going to fill in this box right here? Negative 3x, right? Which is really close to negative 2x. So we have to add the 1x from 1 times x into that box. So the negative 3x plus the 1x combine to get the negative 2x. Okay? This one was fairly easy to factor. X squared is x times x. Negative 3 is negative 3 times 1. You could have swapped those around. It doesn't technically matter which order you do your binomials in. So you take the binomial across the top, set it equal to 0, take the binomial along the side, set it equal to 0, and solve these independently. Okay? One of the questions it asks you is, how many solutions did you come up with? We came up with 2 solutions, right? We got negative 1, and we got positive 3. Then it asks, which strategies did you use? I used undoing, or you could call it inverse operations, right? Some people prefer that term. All right, any questions so far? All right, we're going to take that same equation on page 6 and look at it in part B. Part B says, in thinking about the square root of 2x plus 3 equals x, Miranda writes down y equals the square root of 2x plus 3 and y equals x. How many solutions does the equation y equals the square root of 2x plus 3 have? And how many solutions does the equation y equals x have? So you're going to open up your Desmos graphing, and you're going to graph these two, y equals the square root of 2x plus 3, and y equals x. Do that right now. And I think it's going to let me switch. Okay, let's see. Let's hope. No. Okay. Let me just show them. Miranda says, I'll graph both the functions y equals the square root of 2x plus 3 and y equals x to check the solutions from part A. How will graphing help her determine the solution? Be sure everyone on your team can answer this before moving on. Okay, so if you have both graphs showing at the same time, the solution is going to be what? Where they intersect. How many places do those two intersect? 1. How many solutions did we get on page 5? We got 2. Okay, so here's something that's about to happen. Okay, so Miranda looks at the graph on her graphing calculator and says, I think something is wrong, right? Which you all just said in your head. That's not right. We got 1, and then we got 2. Graph the system on your graphing calculator and locate the intersection points of the graph. How many intersection points are there? You guys just told me they're intersecting at one spot. I got 3, 3. If you hover over it with your little pointer, do you get 3, 3? Yeah? Okay. Does this confirm your solution from part A and explain your results? So on your Desmos graphing calculator, you have an intersection at 3, 3, but at -1, 0, which was what we got on page 5, where are they intersecting? They're not. So you say no intersection there. This is going to be what we're about to learn or call an extraneous solution. So for question 25, it says, when a result from a correctly solved equation does not make the original equation true, it is called an extraneous solution. It is not a solution of the equation, even though it is a result when solving algebraically. Check your solutions from part A of problem 324 algebraically. Okay? So we got 2 answers when we did problem 24, right? We got x equals 3 and we got x equals -1. We know that 3 works, right? We just saw it on the graph. You're looking at it on your Desmos, right? So we're going to take that 3 and we're going to plug it in under the radical where that x was at, and we should get 3, right? Because it intersects at 3, 3. So if we go 2 times 3, we get 6. 6 plus 3 is 9, and the square root of 9 is 3. Does it work? Yes, it works. Okay? So when you take your values for x and you plug them back in, you should be able to solve it for what it should be equal to. But here's what happens when we plug in -1. So under that radical, where the x was at, we're going to plug in -1. It should be equal to -1. So we put a question mark there. Like basically, is it equal to -1? 2 times -1 is -2. -2 plus 3 is 1. And the square root of 1 is 1. Does 1 equal -1? No, and you might just feel like, oh, maybe I just messed up a sign because they're so close, right? Like, it's just positive and +1 and -1. Maybe I messed up, like left off a sign or something. So, like, it might feel like, oh, maybe I'm just missing something, but no, it actually does not work, okay? It does not equal -1, all right? You did it correctly. It just feels like, oh, well, it's so close, maybe it should be, okay? Any questions on part 25? Yes? No, not in this case. No. All right. Any other questions? Turn over to page 7. Question 26 says, the fact that extraneous solutions can arise after solving correctly makes checking solutions especially important. So probably a lot of the time when you first learned how to solve equations, your teacher had you check your answers. And then after you'd done that a couple times, your teacher was like, well, just solve, and once if you get a reasonable answer, then you don't check it as often, okay? So now, because of this thing called extraneous answers, it's going to be important to check your answers. But why does the extraneous solution appear in this problem? Examine the graph of the system of equations, y equals the square root of 2x plus 3 and y equals x, shown at right. Where would an extraneous solution x equals -1 appear on the graph? Why do the graphs not intersect at that point? Okay? So this is basically what you have in your Desmos graphing calculator, right? You've got the square root one here, you've got the linear one here. You see that they intersect, but right here at -1, we've got a point up at +1 and a point looks like a little lower than -1. The reason is when you take the square root of any real number, the solution is always going to be positive, never negative. Okay? That's going to be one of the reasons. If you see square roots in any of these, it's going to limit your answers and sometimes make one extraneous. Okay, so let's practice here. We're going to do A and B, and then in your groups of 4, you're going to do C and D together. So let me move this over. There we go. Okay. So for part A, it says, directions. Complete the following radical equations and check for extraneous solutions. So you're going to see on the left-hand side, I solve it. And then on the right-hand side, I'm going to check the 2 answers that we get and see which one works and see which one is the extraneous solution. Again, we have radicals, okay? So when you have radicals, you're more likely to have an extraneous solution, okay? Inverse operation of taking the square root is squaring. So the first thing you want to do is square both sides, just like we did on the other problem. They're inverse operations of each other, so they cancel out, and you're left with what's inside, the x plus 2. Then you're going to set, right, then you're going to set it equal to 0 by moving this one to the other side by subtracting it, moving the 2 to the other side by subtracting it. So now we have this beautiful trinomial, right? You want to take your trinomial and factor it. You can use the quadratic formula if you like, but this one seems easy, so I'm just going to use the box on it. Factors of x squared are x and x. The factors of -2 are -2 and +1, which will fill in this box with -2x and fill in this box with +1x. So -2x plus 1x will combine to get your -x right there. Let me move it up. It looks okay. So then you're going to take each of your binomials and set them equal together, equal to 0, and solve them independently. These are pretty easy. They're just the opposites, right? Okay? Once you have those 2 answers, you're going to check them. So let's check the 2 first. If we plug in 2 under that radical, we have 2 plus 2, which is 4, and the square root of 4 is 2. That one works great. Okay? Your checking should be way faster than your actual solving, right? Now we're going to plug in our -1. Our -1 plus 2 is 1. Square root of 1 is 1. Does 1 equal -1? No, it does not.